As promised, we will proceed to do a sample problem, and our sample problem will be for a large sample. Again, we have a caveat that we have to do if it's small sample meaning generally defined as less than 30. But let's start out on this problem. An automobile manufacturer claims that the new Cobra EX can go from 0 to 80 miles per hour in 3.5 seconds. Now that's moving, guys. My wife would love that car. I'm just too slow. I'm not into hitting the gas and going through somebody's back windshield. You suspect that this claim is too low. Now think about that just a minute. What if it is less than 3.5? What if it's 3.0? Well, you're still happy. But what if they claim it's 3.5 and it's more than 3.5, that their claim is too low? Well, if it's more than 3.5, then they've deceived you because you expected 3.5 and it doesn't perform at the level that they've asked. It's slower than that. You decide to test the claim using 5% error. So you have a 95% confidence level. Your sample of 500 cars found that the sample mean to be 3.65 with a standard deviation of 0.2. So let's look at doing this just a minute. The first thing we read for information. We find in this that X bar for the sample is 3.65. The standard deviation was 0.2. N is 500. And our alpha level is 0.05, which means our confidence level is 0.95. Now begin to work on the 6-step plan. We need to state the null hypothesis, the alternate hypothesis, the critical value, the test or research statistic, the conclusion, and then write our finding into statements. The null hypothesis is very easy. They claim that it's 3.5 seconds, so HO is mu equals 3.5 seconds. The alternate hypothesis, HA, is that mu is more than 3.5 seconds. So see, we said we suspect that their claim is too low, which means that we suspect that the true average is more than 3.5. Now, we have to establish the critical value. Now, here's the fun part, just a minute. This is where you draw the curve and you label the error and it makes it easier. If we draw the curve, then we think that it's more than 3.5. So our curve it's going to be that mu is greater than 3.5. So we have an upper bounds here and we have an error of 0.05 here, which means that our critical value is 1.645. Now I want you to notice that drawing the curve makes it much easier for you to find the critical value. Also notice that the alternate hypothesis helps you draw the curve. Mu is greater than 3.5. Here's arrows out on this side. The arrow points to the right. The arrow is to the right. So our critical value is 1.645. Now the picture helps. If you try to cut steps and don't draw the picture, then you may find yourself getting mega confused. Now you find the test research statistics. Z-test, the formula is X bar minus mu divided by S over the square root of N. So we need to start solving that problem. So we plug in our values, 3.65 minus 3.5 divided by 0.2 over the square root of 500. Those are the values we got. So we begin to solve. 0.15 divided by 0.2 over 22.36. Z-test is 0.15 over 0.008944. And our z-test statistic is 1.677. So we draw your conclusion. What happened is we had an upper bounds of 1.645. If their claim is true, then 95% of the data lie to the left of 1.645. 95% of the mu's lie onto the left of 1.645. Our z-test statistics actually fell way out here in the rejection region. So z-test falls outside the barrier in the error portion. So our conclusion is we reject H0. What we have done is rejected their claim. And we need to write it into statements. An analysis of 500 vehicles indicate that the Cobra EX goes from 0 to 80 in more than 3.5 seconds. The manufacturer's claim is incorrect. The Cobra EX takes more than 3.5 seconds to go from 0 to 80 miles an hour. So what we have determined is that the manufacturer has misled us with that claim. Now, the hypothesis testing uses a 6-step plan. We write the null hypothesis, the alternate hypothesis. We find the critical value based on the level of confidence. We then do the test statistics. We draw a conclusion, and we write it into statements. Now, guys, this is for a large sample. If we do a small sample, the only thing we have to adjust is the critical value, and we will talk about that in just a moment. Drawing the picture helps. If you don't draw the picture, then it's going to be harder for you to go through these 6 steps. You're making good headway. I want you to keep the faith. You've got this. This is not difficult. Actually, it gets to be a lot of fun because you're testing what a manufacturer says to determine whether it's true or false.